Hey guys, and welcome to the fourth lesson in our four-part series on inequalities. Today we're looking at solving quadratic inequalities. So you're going to want to have a look at our first three lessons on inequalities, and you're going to need a good strong base in solving quadratics in general. So I'm posting both of those series down for you in the description section. If you're new to Team Danielson, let me just explain to you how this works. First, we'll go through a lesson, which includes some examples, and then I'll take you through a pause and play practice exercise where the answers show up at the end. Let's get started. Now let's start with a bit of a reminder. You should know by now that quadratic equations often have two solutions. The solutions, or the roots, are where the quadratic equals 0. So on a graph, we would see that as where the curve touches the x-axis. So here are some different quadratic curves that you might have. Here we've got some positive parabolas. That's where the x squared term is positive. Here I've got one solution, or one root. Here I've got two solutions, or two roots. And here I've got no solution because this curve will never touch the x-axis. And here I've got some negative parabolas. So that's where the x squared term is negative. So here I've got one solution where it just touches the x-axis once. Here I've got two solutions where it crosses the x-axis in two places. And here I've got no solution because this curve will never touch the x-axis. When solving quadratic inequalities, we call these roots our critical values. Remember, when we're solving an inequality, we don't have a single answer. We have a range of possible values. Inequalities tell us if the set of possible values are the points which are on the curve which are either above the x-axis or below the x-axis. Although we're combining a lot of different ideas together here, basically if you can solve quadratic equations, you can solve quadratic inequalities. Here are a bunch of examples of quadratic equations, but remember that before you can solve a quadratic equation, it must first be set equal to 0. In the same way, before you can solve a quadratic inequality, it must first be set either greater than or less than 0. And that's going to help us find the boundary values or the critical values. So these quadratics set equal to 0 could be solved to find either 1, 2, or no solutions, depending on the quadratic. While quadratic inequalities will tell us the set of possible values that x could have. It could have a discrete number of possible values, or it could have an infinite number of possibilities. But the critical values are the points on the curve which tell us exactly which point the x values must either be above or below. Let's start with an example. We can solve this quadratic inequality in exactly the same way that we solve quadratic equations. I'm even going to write this as an equation for you. And this equation is a nice easy one to solve because the quadratic is already factorized and set equal to 0. So I just need to find the two possible values that would make this multiply out to be 0. That's either when x plus 7 is equal to 0 or when x minus 1 is equal to 0. Now remember to keep in mind that this is a quadratic inequality that we're trying to solve. So the solutions we find here are not the final solutions to the quadratic inequality. They are just our critical values. So finding our critical values, those are the points that x is either above or below. We'll rearrange these equations to get x on their own. So for this first equation, x plus 7 equals 0. First I'll move the 7 to the other side. Instead of plus, I'll minus. So that's x equals 0 minus 7. X is negative 7. That's one of my critical values. The other critical value is where x minus 1 equals 0, I'll move that minus 1 to the other side of the equation. Opposite of minus is add. So x is equal to 0 plus 1, which means x must be equal to 1. I've got two critical values in this example. Looking at these critical values now, we know that this quadratic has got two roots. That is, it will cross the x-axis in two places, when x is equal to negative 7 and when x is equal to 1. We also should know that this is going to be a positive parabola because looking at the quadratic, if we expanded these brackets out, we would do x times x, which makes positive x squared. So that's going to be a positive parabola, which crosses the x-axis in two places, where x is equal to -7 and +1. So we sketch this curve showing where the roots are, and we want to know if we want the parts of the parabola which are above the x-axis or below the x-axis. This is the part that often confuses people. Look at your original inequality. Our quadratic is on the bigger side of the inequality sign. That means we want to show the part of the curve above 0. That's the part of the curve above the x-axis. So that's from the -7 over towards the left because it's growing outwards as we go up. So we're looking at the x values which are less than -7. And we're looking at the x values on the other side of the critical value 1, which goes up and out to the right. So the x values that are bigger than +1. So this quadratic inequality gives us two distinct inequalities as our answer. The ranges of possible values for x are either greater than or equal to 1, and I say or equal to because our original inequality includes the boundary value, or less than or equal to -7. Again, my inequality symbol is underlined because the original inequality symbol is underlined. But notice that my inequality symbols are not automatically the same symbol as the one given in the inequality that we started with. Let's try another example to make sure that that was clear. Now this quadratic is not yet factorized, so we're going to have some work to do, but it is set up in the right format. It's less than or equal to 0, but we're going to solve it just like a normal quadratic equation, so I'm going to set it equal to 0. Now to solve this quadratic, I could use a variety of different methods, but I think that factorizing will be the easiest if I can think of two numbers that multiply to make -12 and add to make +4. And I'm thinking 6 and -2. So I factorize my quadratic, and from that factorized quadratic, I can find my critical values either when x plus 6 is equal to 0 or x minus 2 is equal to 0. Solving x plus 6 equals 0, x must be equal to 0 minus 6, so that's -6. And solving x minus 2 equals 0, that will just be x equals 0 plus 2, so x must be 2. So my two critical values, the solution to this quadratic equation, would be where x is equal to -6 or where x is equal to +2. But we don't stop there because this is a quadratic inequality. We need to find the set of values that are either above or below these critical values. So our next step is to sketch our quadratic curve, showing that it crosses the x-axis at these two critical values. I can tell that it's a positive parabola because I started with a positive x squared term, so I'm going to do a U-shaped quadratic, which crosses the x-axis at -6 and +2. And the important part is, do we want to include the x values on the top of this curve or the bottom of this curve? Look at your inequality to decide. We're looking for the x values that make the quadratic smaller. The pinch down side for the quadratic side, it's smaller than 0. So in this case, we're looking at the part of the curve that is below 0, below the x-axis, which is this joined little loop here between the -6 and the +2. It's joined together. What kinds of inequalities are joined together? This is a combined inequality. X could have any value in between -6 and 2. And do we include the boundary values? Look at the inequality symbol. It's underlined. Yes, we do. So our combined inequality answer for this quadratic inequality, putting those values in order from smallest to biggest, -6 and +2, putting x in the middle, and putting in our inequality signs, which are underlined, showing that -6 is smaller than or equal to x, and x is smaller than or equal to +2. Let's try another example to make sure that's really clear and sinking in. First, we need to set our quadratic as if it was an equation equal to 0. I can see here that it's less than 0, But let's forget about the inequality in the first step and solve the quadratic equation. Now this quadratic is nicely factorized for us to make this easier, but we still need to find our critical values. So what x value would make this bracket equal to 0, and what x value would make that bracket equal to 0? Critical values are where 2x plus 1 equals 0, and where x minus 4 equals 0. 2x plus 1 will be equal to 0 when 2x is equal to 0 minus the 1. And getting rid of the 2, x will be equal to that negative 1 divided by 2, so negative 1/2 or negative 0.5, whichever you prefer. X minus 4 will be equal to 0 when x is equal to 0 plus the 4, so that's when x is equal to 4. So I've got my two critical values, but we don't stop there. Next step, let's sketch the curve. Is it a positive parabola or a negative parabola? Look at the original quadratic, 2x. If I expanded it out times x, that's going to be 2x squared. Positive 2x squared, that's a positive parabola. And I can see that it's got two roots, so it's a positive parabola that crosses the x-axis in two places. And those two places, putting them in order, smallest one first, are negative 5 and positive 4. Do I want the top part of this parabola or the bottom part of this parabola? Look again at the original inequality, and we want the quadratic, which is less than 0. So we want the part of the curve that is below the x-axis. Again, that's the joined part of the parabola. So we're going to have another combined inequality. It shows that the x value could be anywhere in between the values negative 0.5 and positive 4. So let's write that combined inequality. Put your values in order from smallest to biggest. So negative 0.5 is smaller than positive 4, and we'll put x in the middle. And this time we did not underline our inequality signs because in our original inequality, this was not underlined. We don't include the critical values in our range of possible values for x. X is greater than the negative 0.5, but less than the 4. Try one more example. So example 4. Here you've got a quadratic. It's a bit tricky here. We've got 2x squared on one side and x squared plus 6x minus 9 on the other. First step, remember we can't solve a quadratic unless it's equal to 0. We can't solve a quadratic inequality unless it's either greater than or less than 0. So our first step should be to get all terms over to one side and leave 0 on the other side. Now I'm going to give you a hint of what I think is generally best. I don't like solving negative quadratics. That is, I like my x squared term to always be positive, so that when I set up my two brackets, it's x and x, not positive x and negative x. So I'm going to move all of my terms from the right side over to the left side. So I've got 2x squared minus the x squared, minus the 6x, and plus the negative 9. Okay, now I want to simplify that, so grouping my likes terms. 2x squared minus x squared is just going to be x squared. So I've got a quadratic x squared minus 6x plus 9 is less than or equal to 0. Now I can set that up as a quadratic equation and solve it to find my critical values. I could use the formula, I could try completing the square, but I think I can factorize. I can think of two numbers which add to make negative 6 and multiply to make positive 9. Negative 3 and negative 3. Hey, it's a perfect square. So there's actually only one solution to this quadratic because both of these brackets will give the same critical value. Critical values, either x is equal to positive 3 or x is equal to positive 3 because both brackets are the same. So shall I sketch a positive parabola or a negative parabola with this one critical value? Go back up to the inequality that I was trying to solve. I made sure it was a positive parabola because it was easier for me to factorize. So I'm going to draw a positive parabola, but just with one root this time. And that one root is where x is equal to 3. Now, do I want the part of the parabola which is above 0 or below 0? Looking at my inequality here, I moved everything over to my left-hand side, which is the smaller side of the inequality symbol. So that means that I'm looking for the lower part of this quadratic. The lower part of this quadratic, there is nothing below the x-axis, but it does touch the x-axis, and my inequality is underlined. I am including the critical value. So this quadratic inequality actually only has one distinct answer, and that's where x equals 3. Now let's just go through a quick reminder of our steps to solving quadratic inequalities before we get into the practice. Step 1, make sure one side of the inequality is 0. Step 2, set the quadratic equal to 0. Step 3, solve to find the critical values. Step 4, sketch either the positive or negative parabola and label the roots. Step 5, determine if the range of x values to be found are above or below the x-axis. Step 6, determine if the solutions will be combined inequalities, two separate inequalities, one specific value, or no possible solutions. Step 7, set up your solution, paying close attention to the direction of the inequality signs and whether or not you need to underline them. Right, time for some practice, and I hope we're ready for this. Here you've got a bunch of inequalities, and I've set them all either greater than or less than 0 to start with. So you really just need to solve them the way you would usually solve a normal quadratic equation, but then remember what to do with your critical values. Sketch your parabola, whether it's positive or negative. Show where it crosses the x-axis, whether it's one root, two roots, or no roots. And look carefully at the original inequality sign to see if you're looking for the x values on the curve above the x-axis or below the x-axis. And watch out, is that inequality underlined? Do we include the critical values in our answers or not? Go ahead and hit pause now and give it a try. I hope you've had a chance to hit pause. I know these ones take a while. Here come your answers. Now this first one, you might have drawn it in two different ways. If you solved this negative quadratic, you would have drawn a negative parabola and you'd have your two critical values, and you're looking for the x values which are on the part of the curve that is above 0. So you're looking for the x values between your two critical values. Had you rearranged this quadratic to move everything over to the right-hand side to get a positive parabola, positive x squared term, everything would be on the smaller side of the inequality, which means you would be looking at a positive parabola, but you're looking for the part of the curve which is below the x-axis. So still the x values between your two critical values. So either way you've done it, your set of possible values for x are -6 is less than x, and x is less than 1. Question 2, again, the way the question is given, it is a negative parabola. And we're looking at a negative parabola, which we're considering the x values below the x-axis. But if you would turn that around to make it a positive parabola, the quadratic's on the right-hand side, you would be looking at the parts of the quadratic which are above 0. So in either case, you're looking at two separate inequality answers, either where x is less than -11 or where x is greater than -1. For question 3, this time it's a positive parabola. So I would assume you all drew a positive parabola. You found your two roots, and we're looking at the part of the curve that is below the x-axis because the quadratic is less than 0. So our answers are x is between -1 and +1. Question 4 is a positive parabola again. This time that positive parabola is greater than or equal to 0. So we're looking at the parts of the curve that are above the x-axis. So our solutions will be two separate inequalities. One where x is less than the lower critical value, so less than or equal to -1. And one where x is greater than or equal to the upper critical value, which is +3. Question 5 is another positive parabola. and it's greater than 0, so 2 inequalities again. Our two critical values were -5 and +1, and we're showing the x values which are less than the -5 and greater than the +1. Question 6, again a positive parabola, and we're looking at the part of the curve that is less than 0, so below the x-axis. So that's the joined part of the curve. It's a combined inequality between -1 and 6. Question 7, as we see, is a negative quadratic, which is less than or equal to 0. So if you drew that as a negative parabola, you're looking at the part of the parabola that is below the x-axis. But if you would turn that around, so you move the quadratic to the other side of the inequality sign, it would be on the bigger side of the inequality sign. So for your positive parabola, you would be looking at the part of the quadratic which is above the x-axis. In either case, you're looking at two distinct inequalities, one which is below your lower boundary and the other which is above your upper boundary. Finding our two critical values, they were -2 and +5. We're looking at the x values which are less than or equal to -2 or greater than or equal to +5. And question 8 finally is a positive parabola with its two roots, and we're looking at the quadratic that is greater than or equal to 0. So we're looking at the part of the parabola which is above the x-axis. Again, two separate inequalities here. One which is less than the lower critical value, and the other which is greater than the upper critical value. So x is less than or equal to -9, or greater than or equal to +1. Now I know this is a lot to take in. I hope that you've understood well. If not, please leave me a comment in the section down below, and I'll try to explain this a little bit clearer for you. If you have enjoyed this lesson, please give it a like and subscribe so that you can see more content like this in the future.